Okay, so let's look at this circular problem. We have this wheel here. We have 1, 2, 3, 4, 5, 6 different forces applied to it. And what we want to try to figure out is the net torque. So what you're going to do is just kind of find the individual torques and either add them or subtract them based on direction. If you want to assign positives and negatives, you're welcome to do that also. By convention, we typically say counterclockwise is positive. That's the conventional direction, is counterclockwise is positive. However, if you don't like that, you'd rather be clockwise, you're welcome to make clockwise positive, just as long as in the end you specify clockwise or counterclockwise. So I'm going to use the kind of the convention. So anyways, let's look at each one. So we'll look at the first one here. We have our force 30 newtons. So we'll call this torque 1, 30 newtons. How far away is it? Radius is 3 meters. Okay, so that first one is going to be 90 Newton meters. Since this is what, clockwise, so I'm going to go ahead and call this negative. Alright, torque 2, we'll make this torque 2. This is going to be 20 newtons, perpendicular to 2 meters. So this is going to be 40 Newton meters. This one is counterclockwise, so I'm going to go ahead and make this one positive. And we'll just go on down the line. Okay, let's look at this one down here. So this one is at an angle. So you have part of the force is down, part of the force is horizontal. Which one do we care about? The horizontal force. So that's the one that's perpendicular, is the horizontal. Okay, so torque 3 is going to be 50. This is 30 the degrees right here. So we're going to use cosine or sine? Cosine. So this is going to be 50 cosine of 3 meters. Oh no, cosine of 30 times 3 meters. Someone help me out. What's the answer for this one? $129?
Yeah, 0.9. So I would do 130.
Alright, torque 4. And we're going to look at direction. So this is counterclockwise. So we'll stick with the positive for counterclockwise. Okay, let's do this one over here. This is going to be counterclockwise again. So we're going to go 40 newtons times 3 gives us 120. And counterclockwise also, make that positive. And the last one is this little guy. Oh no, there's 2 more. This little guy right here, we'll call it torque 5. 60 newtons and 40 degrees. So again, we're going to break it down. We want to make sure we have the perpendicular one. This is perpendicular. Okay. No, it's not. This is perpendicular. Okay, the vertical. F, Y. Remember, perpendicular is perpendicular to the radius. Okay, so this is our radius. This is perpendicular to it. Alright, so are we going to use cosine or sine? Cosine 40 times 2 meters. Someone help me out. 91? 0.9. Okay, torque 6, we'll call it this guy right here. What's torque 6 going to be? 0. Okay, why is torque 6 0? Because it's parallel. Yeah, radius is here. It's parallel. We're just pushing against the wheel, right? It's not going to move if you push that way. I think I have one mistake. Where's that? I have one mistake in torque 5.
Newton meters.
Okay, I have 2 mistakes in number 5. What's the other mistake? The direction, right. So we're defining clockwise to be negative, so I do want to make sure that this is opposite of the counter direction. So that should be negative 91.9. Okay, net torque, we're just going to add them all up. Negative 90, positive 40, positive 130, positive 120, negative 91.9. Okay, and because it is positive, that tells us what direction? Counterclockwise. And again, if you define your direction differently, then that's fine. Just make sure you specify the direction, counterclockwise.